in this question you have a cubic function and you're asked to find the area under the curve. So the cubic function obviously doesn't stop here. The cubic function would extend in both directions. But to find out the area, we'd need to do an integration. So you'd need an integration of y dx. So that's your area. But to find the area, you would need to know the limits of your integration. So you'd need to integrate from the start point to the end point to include all of this in your area. But notice you have this section of the shaded area that's below the x-axis. So we expect the area here to be negative. So this is likely to be negative, or it will be negative. Whereas this area here is going to be positive. So anything above the x-axis will give you a positive area. Anything below the x-axis will give you a negative area. So when they're asking for the total area, you don't want a negative value. So we need to make sure that this isn't negative. So we need to take the absolute value, if you like, of that. We need to take the positive version of that. So to do that, we're going to need to find not just this point and this point, but also this point. So these are the points where y equals 0. So your first challenge will be finding the points where y is equal to 0. Now, whenever you have factors that are multiplied to give you 0, that's good news because it means that each of these factors could be 0. So either x minus 2 is 0, or x minus 5 is 0, or x plus 4 equals 0. So either x equals 2, or x equals 5, or x equals minus 4. So thinking about the graph, minus 4 is going to be the first one, 2 is going to be the second one, and 5 is going to be this third one. So we can label our graph minus 4, 2, and 5. So our area we can now write as the integral from minus 4 to 5 of y dx. That's from minus 4 to 5. But wait, what about this part, which is negative? That's included in there. So to avoid that problem, what we do is we say it's the integral from minus 4 to 2 of y dx plus the integral from 2 to 5 of y dx. So it's this bit and this bit. Now this is going to be negative, so to make sure it's not negative, what you could do is put an absolute value there to make sure that the negative becomes positive. What you could do is change this plus to a minus. That way that this negative becomes positive. Some people, what they do is they change the order of the limits. And that changes the negative to positive. So what I'm going to do is I'm going to put a negative sign there to show that if you get a negative number here, you will get a negative number here. This minus will make sure it's added to this. So let's find out what y is. You can't integrate that. It's going to be difficult. So we're going to expand the brackets. So we're going to multiply out the brackets. So first of all, I can replace this with that because this is what we've agreed the area will be. And now I'm going to try to find y. And to do that, I'm going to multiply these two first, and then multiply by the third term. So y equals x minus 2 times x squared minus 5x plus 4x is minus x minus 20. And then we're going to multiply x by all of those. So it's x cubed minus x squared minus 20x. And then I'm going to multiply minus 2 by each of those. So it's minus 2x squared plus 2x plus 40. Now we can collect like terms. So these two add up together and these two add up together. So that will give me x cubed minus 3x squared minus 18x plus 40. And if I wanted the integral of y dx, that will be the integral of that. So that will give me, let me just put the answer. So that will give me 1 over 4 y to the power 4 minus x to the power 3, because that will be 3x to the power 3 over 3, minus 9x squared plus 40x plus c. Now, you'll see in a second that we're not going to use the constant because we are going to have a definite integral with limits. So let's find each of these definite integrals one by one. So my first area here, I can write as this but with the limits minus 4 and 2. So that'll be 1 over 4, 2 to the power 4, because I'm substituting 2 into each of these x's, and then I'll substitute minus 4 into each. So minus 2 to the power 3 minus 9 times 2 squared plus 40 times 2 minus, and then it's essential that you have brackets, and then you do the same, but this time with minus 4. So it's 1 over 4 times minus 4 to the power 4 minus 4 cubed minus 9 into minus 4 squared plus 40 into minus 4. And if you put all that in your calculator, I'll do that now. will give you 216. So that's the first area. So this top area we've just found, that's this integral. We found that to be 216. Now let's find this second integral. It's exactly the same. We just put in our new set of limits. So this time my limits are going to be 2 and 5. So I'm going to copy exactly the same thing I did before, but this time 2 and 5. So the limits will be between 2 and 5, and I expect the answer to be negative. So let me put that into my calculator. So if I got that right, if I put it in the calculator correctly, the answer is minus 135 over 4. So that's this. It's minus 135 over 4. So my total area will be the sum of these, or the difference of these, to make sure that the negative is treated as a positive. So the total area, let's call this the total area, is 216 minus 135 over 4. So it's this that I can now consider a plus. That's what you need to watch out for. We should never have a negative area. We need to be adding positive areas. And putting that in the calculator gives you 999 over 4. And that gives you 249.75. But we're not going to give that number, we're going to return that number. And the reason is because the question asks for the exact area. And the exact area, whenever you see the word exact, it means they don't want any decimals. Even though you might think that this is just as exact as that, whenever in a question it asks for an exact answer, it means you leave fractions as fractions, you leave surds as surds, you leave pi, you leave exponentials, you leave logs. Okay, so whenever you see the word exact, leave these in. Don't use the SD button to give decimals. All right, so the correct answer, the correct exact answer is 999 over 4, unless we've made a mistake somewhere. Okay, so I hope you found that